So I'm going to give a talk about getting started with Puppet on Windows. A lot of times people in the community, they've been using Puppet on Linux for a long time, not quite sure how to apply those same concepts to Windows, because it really is a different beast. So I want to start with just a kind of hypothetical example where suppose you're given the task of creating a checklist for provisioning, for configuring newly provisioned Windows servers. So you're going to have to do things like configuring automatic updates, creating user accounts, installing some packages, creating some files, settings, registry, that sort of thing. And so one of the things you might do in that example is configuring the time service, right? You need to make sure that it's synchronized. And so a lot of people, hopefully this isn't anyone here, but a lot of companies have things like creating a Word document, putting screenshots in it, and that's their process for automation. Maybe there's a step up from that. Maybe you have a batch file, maybe you have PowerShell, but it's still a manual process. Someone has to run that script on every system. So the goal of this talk, I hope after the talk you'll have an appreciation for that there are better ways to configure your Windows systems. So I'll start with what not to do. Hopefully you can see that. This is a batch script, right? So we stop the time service on line 2. We make registry changes. I don't know, is that too high up or can you see it? Okay. All right. So you configure the NTP server, right? And then you start the service back up. So that works, but there's a lot of problems with this. The first one, if you just, at a high level, you think about this, scripts like this don't scale, right? Okay, you can do this once, but how do you do this 100 times? And because if you have a distributed system, you have lots of computers out there, how do you tell if something's gone wrong? Like how many of your systems actually got this change? Another big one is, well, you've just gone and modified this script. How do you actually test that it's going to do what you think it's going to do? Right, so those are all things that Puppet's actually really good at, and we'll talk more about that. That's at a high level, but if we look at the script itself, we can see some other problems. For example, on line 2, if the time service is already stopped, then the script is going to fail. Right, so the script is making assumptions about the environment that it's running in. So that's where you get these handcrafted artisanal batch files or PowerShell scripts that try to take into account, oh, I'm running in this environment, so I need to do this other thing. And finally, one of the main problems here is if everything is configured correctly, the script is still going to restart the time service unnecessarily, which it's a time service, so that doesn't really matter. But if this was your web server, that would matter. So Puppet is really good at determining if the current system matches the desired state, and if it does, then it doesn't need to make any changes. So I'd posit that surely we can do better. So about me, my name is Josh Cooper. I'm a principal software engineer at Puppet. I've been with the company since 2011. Been leading the Windows development effort. We now have a Windows team. After the last couple years, we've had a Windows team working on this. I'm also a member of the platform team, so you might see me in IRC or commits to Puppet or Factor. And also, so this is the PowerShell module that I wrote. Can people raise their hand if they're actually using this? Okay. So maybe 15 people. One thing I just want to mention, if you are using this, use the Puppet Labs supported module instead. All right. Okay, so we've talked, you've seen a couple of presentations now about Puppet. And I'm going to talk about briefly what is Puppet and how Puppet on Windows works, right? So we're going to talk about things like what does it mean to run an agent on Windows? So I'll cover like installing Puppet, actually what applications get installed as part of that process, and some best practices for how you can effectively manage Windows. So Lindsay talked about the 4 steps as part of the normal Puppet process. And this slide is showing the, at the top there is the first step of defining what your desired state is supposed to be like. So Puppet has a simulation mode, allows you to basically, in a development environment, you can, or even in production, some people actually do this, they'll run Puppet in a no-op mode, simulation mode, and validate that that there's no unexpected changes. Then you can put Puppet in an enforcing mode, and it will automatically correct for any configuration drift. And finally, one of the things that's really important about Puppet is that it will report on configuration changes that it made, which is really important for auditing, and also just what's in your environment. So this is an example of that batch file that we had earlier expressed as a Puppet manifest, right? So we have, in this process of taking, legacy batch files, PowerShell, that sort of thing, even Word documents, and converting them into Puppet code is what we call Puppetizing. So here I have 2 resources, a registry value that I'm managing, and the time service. And so in Puppet terminology, we call a manifest as a thing that these resources are defined in, a text file, and it's expressing the desired state of these resources. One thing I want to point out, we're not describing anything about how Puppet should make the change. We're just expressing what the desired state should be. So let's look at this example in a little more detail. So we have a registry value, and that path is, HKey local machine system. It's a long path, so I left out some of the details. But we're ensuring that the registry value is present, that it's an array type, which corresponds to reg array. It has the specified data values in that order, and it has a relationship with a service resource that we'll talk about in a minute. Do want to mention that Puppet supports managing all different registry keys, registry values, and all of the typical registry values that you'd expect. So we have the time service. So this is Puppet's way of saying, I want to ensure that the service is running, and I want to, on Windows, the enable equals true means that it's an automatic service. You can also say manual if you want a manual startup type. Also note that we're specifying the short name of the service. The display name is sensitive to different locales, so we want to make sure that this works consistently across systems. All right, so I mentioned that there's a relationship between these 2 resources, and this really gets at what I was mentioning earlier about in the batch file. That batch file will restart the service even if no changes are actually necessary. So this relationship basically says that the registry value should be evaluated first. So when Puppet runs, it's going to check if the current state matches the desired state. If not, it'll make that change. Then it'll process the time service because the time service is dependent on the registry value being correct. The other thing is that if, for example, let's say the service is already in the correct state, but only the registry value needs to change. So that notify basically means if the registry value changes, Puppet detects that it's not in sync, it will automatically restart the service to pick up the new change. Right. So all of these concepts, we talk about registry values and services. This is actually true for all Puppet resource types. And finally, one of the most important things is that if the registry value and the service are already in the correct state, then Puppet doesn't do anything. And the report will tell you that it didn't have to do anything, which is great for auditing. Okay, so that's basically, that's a simple example, and gives you, for people who are new to Puppet, gives you a mental model about how Puppet works. So how does that actually work on Windows? Like so we have a manifest, but how does that actually work? So Well, today I'm going to be talking about supported platforms that we support, how you install the Puppet agent, different applications that are installed once you install Puppet, and the types of resources that you can manage. So first up is supported platforms, and you'll be happy to, maybe this is news, hopefully it's not, 2003 will be end of life in July of this year. And Puppet supports 2003 and up on server platforms, and Vista and up on consumer platforms. Yep. Okay, so let's install Puppet. Here's PowerShell code, 2 lines. One of them is for a variable. Basically, we host our MSIs on our website. You can download, this is a PowerShell command for running MSI exec. Will automatically download the MSI. It'll install it quietly, so non-interactively, and it'll wait for that installation process to finish before moving on. So this is a great way if you're trying to do some automated, you have a workflow where you need to install Puppet and you want to use that bootstrapping process to then use Puppet to install the other things. You can see that we support a number of MSI properties for customizing where Puppet gets installed. Things like the Puppet Master server is something you're almost always going to want to specify. And also, you can configure the, basically when you install the MSI, it will install a service that runs in the background. By default, it's an automatic service. And you can customize that. You can change it to a manual service, and you can specify the user account that service will run under. And so a lot of people configure that to be a domain service account. And if you do that, Puppet will automatically add that account to the local administrators group. A couple of things I want to mention. The MSI has everything you need to run. So it contains Ruby, it contains all the gem dependencies, it contains Puppet, Factor, Hiera, basically everything you need to run Puppet on Windows. Also, it doesn't require a reboot. It's not installing .NET framework versions and requiring reboots or any of that nonsense. So I have 3.7.1 up there. One thing I want to mention, we're up to 3.7.3. 3.7.4 should be out any day now. I'm actually explicitly specifying the 64-bit MSI that is new as part of the Puppet 3.7 release. And I'll talk more about that in a little bit. Okay, so we just downloaded something from the internet. We installed it on our box, and it's running as local system. Like, what could go wrong, right? So, so we take security seriously at Puppet. We digitally sign all of our MSIs with Authenticode certificate issued from Thought. And that ensures that it hasn't been modified since we published it. So if you do download it, and you don't see this, then I wouldn't install it. So I mentioned that we added support for a 64-bit Ruby, and I'll talk more about why that's important. But for those of you who know what sysnative is and file system redirection and all of that, my condolences. Yeah, it's been a painful process. But this is Process Explorer showing the Ruby process running as a 64-bit image. So the basic thing is, if you have a 64-bit operating system, you will almost certainly want to install the 64-bit version of Puppet, which makes your life a lot easier when you're trying to manage that platform. Okay, so we've installed Puppet. What can we do? So one of the things I really like about Puppet is right away Puppet can tell us about your system. It doesn't require, we've installed the agent or the Puppet agent on the system. We don't even have to connect to the Puppet master yet. Some people don't. Some people actually run in a masterless environment so that there's only agents. And so I'm going to talk about 3 applications specifically. The first one is resource, the second one is apply, the third one is agent. Okay, so Puppet resource. So some of you may know about the resource abstraction layer that Puppet has had. That's what Puppet does, right? You have a type that defines what a resource should look like, and it abstracts away some of the platform-specific details about that. So here we have, on this first command here, I've installed Puppet, I can immediately start running commands. I can say, hey, Puppet, tell me about the Win32 time service. And it'll tell me this is the current state. It's currently running, and the startup type is manual. That's kind of cool. Of course, there are Windows-specific commands for all of these things, but if you're trying to manage Windows and Red Hat and other systems, remembering all of the details about that can be a lot to remember. So the other thing that's kind of cool is on the second command, you can actually, from the command line, say, you know what, actually, I want that to be an automatic service. So I'm going to set enable equal true. And when Puppet runs, it compares the current state with the desired state of all the properties of that resource. So it's saying, okay, for this time resource, I'm going to ensure that it's running and that enable is true. And you can see in the output that Puppet only changed that one aspect. It said, oh, it was manual, now it's true. And it didn't change the other ensure state. So that's Puppet. You can interact with Puppet for a single resource, right? But one of the other things that's really cool about Puppet, oh, actually, before I do that. So in this case, this is true for any resource type. It's not just services, and it's not just on Windows. This is any platform for any type that Puppet knows about. It can tell you about your system, and you can interact with it on the command line like that. So the next thing is Puppet can tell you about all instances of a type on your system. So Puppet resource package will tell you about all packages that are installed, the names and versions. And this applies for both executable installers as well as MSIs. One thing, some people naively use WMI to get this information, and you're not going to want to do that because WMI will cause a consistency check to be done on every MSI that's installed, basically reinstalling that application, which is not something you want to do. So we actually give you the same view that add remove programs does. This data is obtained from the registry. So these correspond to the display name and display version properties that are in there. But this is kind of useful because now I can get some sense about what's on my system. I can use this as a basis for creating a manifest, right, to describe what the desired state should be. For example, if I have one system that I'm working with, get it into the known state, use Puppet to tell me what that state looks like. Okay, so we talked about Puppet resource. The next application is apply, which is, if we move in complexity levels, we make things a little more complex. We have more than one resource. We have relationships between them, among them. And so we, like our example that we saw earlier, we had a registry value and a service. We put that in a manifest. In Puppet, manifests by convention end in .pp. So I'm going to run Puppet apply. I'm going to say, I want Puppet, make the system look like this. And so Puppet will do that. I'm also running with --no-op, which is Puppet's simulation mode. So this will have Puppet, it'll tell me what it would do, but it won't actually make any changes, which is pretty cool. And here you can see that the time service is currently stopped, and Puppet would have changed it to running if I didn't use the no-op flag. And the third application is the agent, which is what we've talked about. So you've seen a couple slides about this. I'm not going to basically the node collects facts, sends the facts to the Puppet master compiles a catalog, sends that back to the node. The node ensures the current state matches the desired state, sends a report to the Puppet master, which inserts it into PuppetDB. Right, so that's the basic flow. Some things that are specific on Windows about the Puppet agent is, so I mentioned it installs it as a service running as an automatic service by default. You can change that installation time. You can even use Puppet to change its own service configuration, which is kind of cool. You can also, when Puppet is running, it will log everything to the Windows event log. So all of the, there's an application event log, contains all the Puppet events. You can filter by the source, the event source, which will be Puppet, that sort of thing. Okay, so let's talk about, so now that you have Puppet installed, you have some applications, different ways of running Puppet, what can you actually manage? So this is where we talk about resources. And there are a number of core resources that Puppet comes with out of the box that you can manage. We recently announced a Windows module pack that I'm going to talk a little bit about, and community modules, and tooling for creating manifests and managing your modules. And when I say resources, a lot of times there's a lot of terms in Puppet that are overloaded, but when I say resource, I'm referring to a particular type of a resource, like at the registry value that we saw, or the service. Those are different types of resources. So hopefully that makes this have more meaning. So these are types of resources that Puppet can manage out of the box. So the exec type are things like, executables, batch files. You can run PowerShell through an exec type, but there's actually a module for that. So the file type includes files, directories, and symlinks on Windows where symlinks are supported. And these are actual symlinks, not junctions, which is kind of a different thing. Puppet can also manage the host file. It's the equivalent of Etsy hosts on Windows. Puppet can also manage local user and group accounts. And this includes managing the administrator's group and adding members that are either local accounts or domain accounts. Puppet can also manage packages, which we've talked about, MSIs and executables. Unfortunately, Windows doesn't really have a package management solution. We'll talk a little bit about Chocolatey in a later slide. I know Microsoft has introduced OneGet, but my understanding that basically OneGet just piggybacks on top of the Chocolatey data feed. It'll be interesting to see how that evolves over time. And finally, so we talked about services, and scheduled tasks are what you'd expect, right? Windows scheduled tasks. Okay, so we just announced the Windows module pack, and this was a way of organizing Windows modules that are pretty critical for managing your infrastructure. So the way this is organized, there's a link to that particular module on the Forge. And on the left side these are supported modules that are included in that pack. So things like the ACL module, which allows you to manage Windows security descriptors in all of their gory detail, right? So you have owners and groups and propagation and inheritance and access control entries and all kinds of fun stuff. There's a PowerShell module, which is really convenient for running PowerShell code. You can literally drop PowerShell code into a module that uses the PowerShell provider, and you can execute PowerShell through Puppet. There's also the reboot module, which allows you to chain reboots as part of your application deployment. And there's two basic modes that it supports. One is There's the common case where you install an application and that application requires a reboot to complete installation. So we support that direction. There's also the case where certain things like .NET framework will not install if a pending reboot, if a reboot is pending. So you can use the reboot module to ensure that the reboot pending state has been cleared before it attempts to install .NET. And finally, we have the registry module we talked about. SQL Server I have up here. This is a new module we just released. This is, technically it's not part of the module pack, but it is a supported module. And when I say supported, Lindsay talked about this, it means that it's tested and maintained and officially supported by Puppet. The modules on the right, this is kind of a new thing for us. We have approved modules, which are modules from the community that we basically recommend. You know, if you go on the Forge now, you'll find several different Windows feature modules. And this is, OpenTable has contributed these, and these are things that we've looked at, we've vetted, and they meet our expectations for quality and usability. And I expect that this list will grow over time as more and more people contribute modules to the Forge. So community modules. This is also, if you go to the Forge, you can click on, show me all the community modules, filter by operating system. This will give you this list. These people in particular have really made significant contributions to the Windows ecosystem. So Paul Stack and Liam Bennett at OpenTable, they've really been instrumental in writing modules and improving the testing process on testing. Beaker is our automated testing framework, and they've made a number of improvements to that. Also, Rich Siegel has a number of modules on his personal GitHub page, so you're probably best getting them there. We're working on him, trying to get him to publish those to the Forge, but he wrote the Chocolatey package provider and also the OneGet package provider. And the reason that's important is you can describe package resources on Windows like you do for Yum and other Unix operating systems. So specifically, you don't have to specify the source of where to go get that package because Chocolatey knows how to do that. And that's an area that we expect to improve upon to make that process easier, so less assembly is required to put all the pieces together. Mark Sutter recently contributed a DSC module, which is desired state configuration, which is Microsoft's product that they've announced. Is anybody familiar with DSC or has used it? Okay, so maybe about 15, 20 hands. Yeah, so DSC, I just want to take a minute to talk about that a little bit. So Microsoft's desired state configuration is essentially a clone of Puppet. If you look at their syntax, it's exactly Puppet. Ensure, present. The only difference being they capitalize ensure, right? But this is important for Puppet because Microsoft has the expertise for knowing how to manage their operating system and applications that they publish, right? So it's a natural thing to want to extend Puppet's capability and allow Puppet to be able to manage those things. So the DSC module that Mark wrote allows you to do that. It's not, well, he's using it in production, but we're looking to work with him and make improvements to it. One of the really nice things about it, which is unique, is so Microsoft releases waves of DSC packs that have new functionality, and Mark's module allows you to automatically generate Puppet types and providers from Microsoft's MOF file format, which is essentially their schema for defining what DSC resources look like. So you do that once, you take the result, now you have types and providers for all your DSC resources. Now you can express DSC in Puppet, and you can set up dependencies between DSC resources and Puppet resources, all within a Puppet manifest. Okay, so we've talked about modules, which are ways of extending Puppet, but they don't come with Puppet out of the box. So how do you get them? And the way you do that is using the module tool. And if you're using a master agent configuration, then typically you'd run this command on your Puppet master. You'd install your modules onto the master. When the agent runs, it automatically pulls down the code that it needs, and only the code that it needs. But for some people who, especially if you're developing a module, if a common scenario is using Vagrant to provision Windows boxes, so in a Vagrant environment, you need to get the module onto the Windows system, so you can use the Puppet module tool for that. And this example shows Puppet running on Windows box and making a connection, an authenticated SSL connection to the Forge, kind of important. The registry module installs. It has a dependency on standard lib, which also gets pulled in and automatically resolved. So if you install the Windows module pack, it's actually a meta module, which means it just has pointers to all the most recent releases of the ACL module, PowerShell, et cetera. So you'll see those dependencies get pulled in automatically. So we've talked about resources and how modules allow Puppet to be extended. And so you want to write a manifest, right? So, if you're a Linux developer, you have a lot of choices, right? Vim, Emacs. And at Puppet, we use pretty much everything, Sublime and TextMate, everything else. But if you're in a Windows environment, as Lindsay was saying, they're used to a different tool chain, right? So maybe they're used to IDEs, they're used to, IntelliJ or Visual Studio. So Geppetto was a product that we acquired through our acquisition of Cloudsmith. And so Geppetto is an IDE for creating manifests. It has, it'll give you full syntax highlighting and error checking. It's actually pretty useful if you're looking to learn the Puppet language, if you're not sure exactly what the right parameter is for a particular resource. Also in April, our founder, Luke Knies, keynoted at Build 2014. And Luke and Mark Rusinovich deployed sysinternals using the manifest shown here. And this is actually it's pretty big. It's a Visual Studio plugin that allows you to create manifests and publish to the Forge directly from within Visual Studio. Okay, so we've talked about installing Windows, installing the agent on Windows, different types of resources and modules, and different tooling around that. But how do you put all the pieces together in a way that makes sense? Because fundamentally, Windows is a little bit different. So one of the things that people almost always run into is quotes and interpolation. So this is a registry value resource taken from the previous slide, actually. So here, let's say you want to replace the task manager with Process Explorer. So that's a registry value that you have to change. The basic rule is in Puppet, in Windows code, you want to use single quotes. And in single quotes, you can use single backslashes like that. Actually, the registry is a little funny. You have to use backslashes as a separator character. The / can actually be part of the registry key name, which is really awesome. But so we've assigned this value to the task manager variable, and so then you want to use that variable to construct other paths. So the way you do that is you interpolate that value by putting it in a double quoted string. As soon as you double quote, you need to use double backslashes, right? Good times. Okay, Windows accounts. So I mentioned that you can manage the local administrators group, and you can configure its members to be either local or domain accounts. And Windows has various forms of account names. There's a short version, there's a SID, there's a domain qualified, and there's others, but these are the three that we support. And internally, Puppet will always convert those to a SID and compare the SID when determining the canonical name for that account. Case sensitivity is unfortunately something that we have to deal with. The basic rule is a lot of times Windows resources are case insensitive but case preserving. So just make sure you use the case consistently. In this particular case, this is taken from a manifest that's used to provision our Jenkins slaves on our Windows boxes. And you want to make sure that, for example, that before relationship specifies the Jenkins slaves resource, and you have to make sure that matches. So I was mentioning about 64-bit Puppet, and the reason this is important is because on the left, we have the before 3.7. And if you're trying to manage a file, or you're writing a custom fact that executes a command that happens to live in this directory, the System32 directory may or may not be what you think it is. So if you're a 32-bit application trying to access System32, you will silently be redirected to a different place. So you end up running, the 32-bit version of CMD or Reg, take your pick. So up until now, the recommended approach has been to use the sysnative alias as a way to escape file system redirection. But it gets complicated because now when you're writing your manifest, you have to know, wait, is a 32-bit agent going to be executing this, or is a 64-bit agent going to be executing it? Because they're not equivalent. So in 3.7, we've added a core fact, System32. So on the right, this is what you want to do. Just use the fact. It'll automatically resolve to the native System32 directory, regardless of the Ruby architecture that you're running in. Does that make sense? All right.
So just a quick question about that. What if you're using 64-bit Windows and 64-bit Puppet agent, but you're managing a 32-bit application and you need to check something in the 32-bit system?
Yep. So then you would use the syswow, whatever it is.
Syswow 64.
Yeah. Okay. Okay, so the other thing that people commonly run into is UAC. So basically, Windows has the ability you can be a member of the administrators group, but be running with a restricted process token, right? So you don't have full privileges. And this is a way that you can use to determine which context you're running in programmatically. The one on the top is the one that is running with privileges. The one on the bottom is using the administrator SID in the deny-only context. So the most important thing, just to remember, if you're running Puppet Agent, make sure you're running in an elevated context. Okay, so when Puppet runs, it manages SSL keys, it has settings, it creates local copies of reports that it creates. It also caches the catalog that it ran, that it last applied. All this information is stored in either in a machine context or a per user context. So if you're running with elevated privileges, it's going to store that in a machine context under common app data. So in recent versions, that's going to be under program data, which is also hidden by default, which is great. And on 2003, you'll find that under the documents and settings, all user application data. On the bottom, you can see I'm not running with privileges, so I'm running in a per user context. So it's going to be in the .puppet directory under my home directory. Right, so that can confuse people because they'll edit something in the system location, but they're running in a user context, and that the Puppet server setting doesn't seem to take effect. Okay, so Puppet was originally designed for managing Unix systems, and our goal within the Windows team has been to ensure that Windows is a first-class operating system. We've hired people with a lot of Windows expertise. We've created a continuous integration system to extensively test on Windows, both the platform and modules. And we've built a healthy community of Windows users and module content. And that's where we need your help. So if you haven't already, I recommend trying out Deploy Puppet on Windows, ask questions, join the community, and help make the Puppet ecosystem better. So next steps, there's documentation available on our website. There is a virtual training course, Puppet Essentials for Windows. There's Google Groups, Puppet users, and Puppet Dev. I think you'll find that the community is really open to new people and really helpful. If you're new to Puppet, I recommend using the Puppet users mailing list. The Dev one is about Puppet itself, internals of Puppet, that sort of thing. We also have ask.puppetlabs.com and our ticket tracking system. Recommend searching Google before filing new tickets on that. And also, kind of next steps, I've talked about at a basic level about Puppet on Windows. If you go back to the our PuppetConf 2014, there are a couple of really great videos from Ethan Brown, who had a talk, Puppet for Windows users, showing an IIS application deployment, configuring app pools, creating users, setting permissions. It's a really great combination of all the building blocks for a realistic Windows deployment. And also Rob Reynolds had a talk about plugging Chocolatey into your Puppet infrastructure. And finally, you speak Windows? If so, we'd love to talk to you. We're currently hiring a Windows engineer on our team. And that's it. Thank you. So does anyone have any questions?
How do you tie the output of a PowerShell script into the log of Puppet?
So the question is, how do you tie the output of a PowerShell command into the log for Puppet? So basically, when you're writing, so if you're writing a manifest that uses a PowerShell exec and you have a PowerShell provider, there's basically different methods you can use to emit either error messages or warning messages, and those will appear in the log automatically. Any other questions? Over here.
With PowerShell, it seems like that's getting less out of declaration and more into procedures. There could be moves to get away from that.
You mean on the Puppet side or on?
Wherever it can be made possible.
Okay. So the question was, how are we going to move away from using PowerShell in a, what did you say?
Declarative over procedural.
So how to make it more declarative? Yeah. It's an area that we're looking at. One thing we want to improve is reducing the number of times that we actually execute PowerShell. So having a persistent PowerShell process running and using IPC to invoke multiple commands. And basically getting better integration with the PowerShell runtime within Puppet. Does that make sense? Okay. Question?
Yeah, so feature-wise, I think there's obviously some overlap between what you can do with Puppet and another Microsoft-based solution, say like Group Policy.
Yep.
What are like the advantages or disadvantages, or if you have somebody that's trying to implement Puppet in Windows, how do you work together with that team that manages Group Policy to decide what goes in Puppet and what goes in Group Policy?
Yeah, so the question, so I'm just going to take that last part. How do you decide what to put in Group Policy? How do you decide what to put in Puppet? And it really depends. So, Group Policy immediately falls down as soon as you're talking about managing something that Group Policy doesn't know about. That's an obvious, that's a good place to use Puppet. But also, Group Policy, it's not always obvious. If you make a change, it's not always obvious if that change has been applied consistently throughout. Like, the reporting is not very good. How do you roll back? And also, how do you test changes before you push into production? Puppet, those are things that are just built into Puppet and not specific to Group Policy.
This is a more general question. Can you comment on some use cases, examples of use cases you've seen for consumer versions of Windows?
The most common one is a developer workstation. So there's, some people use Packer as a base template, and they'll create an image and then use Puppet on top to, make the smaller changes, perhaps they're a little bit different.
What about in production?
So in production with consumer versions, I know that we have some customers that are using that more on, again, the developer workstation. Not as much, I can't think of any examples at the moment. Other questions? Up here?
Is Puppet Labs maintaining the Puppet agent that's part of the Azure ecosystem, or is Microsoft doing that?
So I didn't mention that, just for time's sakes. Yeah, so we have both so the question was, are we maintaining the agent that's in Azure, or is Microsoft? And the short answer is us. So in Azure, we have two offerings, basically. There's in the Azure Gallery, we have a Puppet Master image that allows you to easily provision Puppet Master. It's an Ubuntu 12.04 LTS image that you can deploy, right? So that is actually us publishing that image into Azure. And the same thing is true for the agent extension handler, which is a way to, anytime you provision currently Windows VM in Azure, you can automatically have the Puppet agent installed as part of that process. So that it's us doing the publishing. Other questions? Yep.
You said that Puppet can run PowerShell code directly, not just input it into the
Mhm.
Puppet. Are there any limitations as far as that's concerned, as far as running external modules like managing Exchange or Hyper-V or anything like that, from what you actually run for raw PowerShell from Puppet?
So the main thing is that any variable defined in the context of one resource is not going to be visible outside that resource. So if you're managing a registry value and you have a PowerShell object, currently you can't then essentially export that PowerShell object to some other resource that might need that information. Does that make sense? Okay. Yep.
Sorry, one more.
Yep.
Can you use Puppet to manage PowerShell snap-ins?
Like the modules that you import?
Yeah, like I need Active Directory
Yep.
modules, so ensure.
Yeah, I believe those, you just have to put them in the right place in the PowerShell module path, which is one reason why you want to be running a 64-bit Puppet on a 64-bit OS, so you don't have the file system redirection problem. Yep.
One more thing about that. PowerShell 3.0 dynamic import modules is based on command line.
Mhm.
So in that instance, it will automatically import the AD module. Is that something Puppet can handle, or is it not able to pass those correctly?
I'm not sure about that specific behavior. I know if you can explicitly import it in your PowerShell command, then you should be able to do that.
Yeah, the 3.0 no longer has implicit import requirements.
Right, it just happens automatically. Yeah, I don't know the answer to that question.
It isn't working. Is it working?
Yep.
Cool. So I'm going to have to call it on the questions there, but we're going to have a break, and Josh will be here if you have more questions for him. Thank you very much, Josh.
Thank you.